So this problem says that we're throwing some scrap iron, and iron is the Fe, iron, into a gold nitrate solution, and it causes the gold metal to pop out. So this stuff pops out. How much 0.5 molar gold nitrate solution would we need to react with 224 grams? So we want this 224 grams to all come, this 224 grams to all come out. And this stuff is 0.5 molar. So remember that if we've got 1 liter of the gold nitrate, that means we've got 0.5 moles of AuNO3, 2. Okay, and we've got 224 grams of iron metal. Well, for every 55.8 grams of iron, there is 1 mole of iron. And we've got 224 grams of iron. So we're going to multiply this by 4-ish, close to 4. 4 would get us to 220. Yeah, it's around 4. Let's call it 4. It's close enough. Times 4, that would get us 4 moles of Fe. Well, if I've got 4 moles here, I multiply by 4/3. Multiply by 4/3, so that's 8 divided by 3 is 2 2/3. So about 2.7 moles, let's call it, AuNO3, 2. So I got to get rid of 2.7 of these. So let's just use a different color here. I need a lot more than 1 liter, don't I? 2.7 moles of AuNO3, 2. So to get from 0.5 to 2.7, I'd have to multiply by a little bit more than 5. 5 would get me to 2.5. 0.1 would get me to 0.05, maybe 5.4. So we're going to need 5.4 liters of AuNO3. Okay, so in this problem, we've got an acid. We'll represent that with our red, and we've got a base. And we're trying to figure out of our acid, we'll do that one in red, our phosphoric acid. We've got 36 milliliters, but we're looking for the concentration, which again means molarity. And then we've got a base, and we've got 80 milliliters, and it's a half a molar. So I know that if I had 1 liter or 1,000 milliliters, I'd have 0.5 moles of NaOH. I did not use that much. I only used a small fraction, or 80 milliliters of this stuff. So to get from 1,000 to 80, I'd have to multiply by 0.08. 0.08. I know that 8 times 5 is 40, but I've got 1,000th of that because I've got 2 spaces here and 1 space there, so that's 1,000 places that I'm losing. So 40 over 1,000 is 0.04 moles of NaOH. Okay, and that is a 1-to-3 ratio here. So for every 1 mole of H3PO4, I've got 3 moles of NaOH. And this time I've got 0.04 moles of NaOH. So to get from 3 to 4, I'd have to multiply by 4 over 300. And so that's here, 4 over 300, because I got to lose those 2 places. So 4/3 would be 1.33, but I got to lose 2 places, so the answer here is 0.0133 moles of H3PO4. Okay, but here's the problem. We've got, back over here, we've got only 36 milliliters of this H3PO4. So for every 0.0133 moles of H3PO4. There is 0.036 milliliters of H3PO4. Okay, and I need this to be, or sorry, liters. I need this to be 1 liter of H3PO4. So we're going to multiply by about 330. And we would have 0.399-ish moles of H3PO4.